Implications. Released in 1977, the Voyager 1 probe became designed to discover planets past our Sun device. It handed all expectancies, visiting past the heliosphere and into interstellar area. Its task has usually been to push the boundaries of our knowledge, sending back priceless statistics that ground-based totally telescopes ought to never seize. This engineering wonder, created by way of the brilliant minds at the Johns Hopkins Jet Propulsion Laboratory, has ended up our golden messenger to the cosmos, revealing the breathtaking wonders that exist within the long-way reaches of space. Recently, Neil deGrasse Tyson confirmed that Voyager 1 had detected 500 unidentified items peacefully gliding through area. The discovery shook the scientific network, even affecting the most pro researchers. Scientists, engineers, and astronomers right now jumped into the race to decipher the facts and understand the character of those mysterious objects. The preliminary confusion and fear that include being confronted with a seemingly unsolvable conundrum are palpable. To comprehend the significance of this discovery, we must apprehend the significance of Voyager 1. The spacecraft has been a dependable and regular supply of groundbreaking information for nearly 50 years. It has traveled farther than another man-made item, currently more than 233 billion miles from Earth. Notwithstanding its age and the harsh conditions of area, Voyager 1 continues to function optimally way to its twin redundant laptop structures and revolutionary electricity control strategies. Information of the invention spread, and some scientists considered the opportunity that it become in mistakes. They recommended that Voyager 1's age would possibly have stuck up with it, causing it to transmit faulty information. But, given the spacecraft's track file and the reliability of its structures, this rationalization appeared not likely. The statistics came from Voyager 1, a spacecraft that has always surpassed expectancies and provided us with correct data about the universe. When scientists took a better look at the information, they found out the magnitude of what they were dealing with. These 500 unknown objects all of a sudden appeared with none on the spot reason behind their presence. 1 minute we had no idea they existed. The subsequent they dominated our scientific discourse. The medical network become on excessive alert, with absolutely everyone looking to understand this unprecedented discovery. The adventure of Voyager 1 became not without its challenges. The spacecraft changed into initially designed to perform for best 5 years, but thanks to careful energy management and strategic making plans, it was able to retain its challenge for almost 5 a long time. This longevity is a testament to the ingenuity and willpower of the engineers and scientists who designed and maintained it. The spacecraft's energy management techniques, consisting of selectively powering down needless systems, performed a key position in extending its lifespan. The facts transmitted by Voyager 1 turned into perplexing. The spacecraft became sending return telemetry statistics indicating the presence of these unidentified gadgets. However, it was nonetheless responding to commands from undertaking manage. This anomaly had not precipitated any error detection structures that are designed to spark off in such conditions. The spacecraft persevered to perform commonly with its antenna pointed in the direction of Earth, making sure endured verbal exchange. Voyager 1's achievement can be attributed to its twin redundant structures. These systems permit for seamless transitions between components, thereby keeping the spacecraft's functionality. Whilst designing Voyager 1, engineers blanketed numerous units of manipulate subsystems, flight statistics systems, and mindset and docking manipulate systems. This redundancy is prime to its resilience, allowing it to operate efficiently even in the harsh environment of area. One of the maximum important components of Voyager 1's durability become its potential to control its electricity. The spacecraft depended on radioisotope thermoelectric mills, RTGs, to generate strength, but the electricity of those generators declined through the years. Engineers carried out a diffusion of techniques to preserve and optimize electricity intake, together with selectively shutting down non-vital structures and the use of adaptive energy control strategies. Those measures had been instrumental in preserving Voyager 1 operational. As scientists endured to research the ambiguity, they determined that the Mindset and Coupling Managed Subsystem, AACS, turned into the supply of the mysterious information. This subsystem, accountable for orienting the spacecraft and controlling its motion, transmitted telemetry records through an onboard laptop that have been decommissioned for years. The unintended intervention of a previous laptop corrupted the records dispatched lower back to Earth. This discovery led scientists to a solution. They requested AACS to redirect the telemetry facts to an appropriate lively statistics processor. This low-risk degree proved effective, fixing the instant problem. The research, but underscored the complexity of managing a spacecraft at such an extraordinary distance. Communications delays due to the 233 billion miles among Voyager 1 and Earth delivered to the mission. Because of the sizable communique put off, about 22 hours for a signal to travel from Earth to Voyager 1 and returned, Project Control had to be meticulous in transmitting commands. Any mistakes may want to cause prolonged delays and complicate the prognosis of abnormalities. This careful and precise planning became crucial to the project's achievement. While the preliminary anomaly has been resolved, the broader implications of this discovery continue to be. Scientists keep to contemplate the origin and nature of the 500 unknown gadgets discovered by using Voyager. The possibility that they could pose a chance to the spacecraft or maybe Earth has no longer been absolutely dominated out. Researchers are exploring an expansion of hypotheses, such as cosmic radiation, excessive temperatures, and micrometeorite impacts as potential contributing elements to the anomaly. The Deep Area Network, DSN, a massive international community of radio antennas, plays a vital position in preserving contact with Voyager 1. The community helps communicate among Earth and deep area missions, ensuring we get hold of valuable records from far away in our Sun gadget and past. DSN talents are essential to the continued achievement of the Voyager task. As Voyager 1 maintains its adventure through area, we are able to best speculate about the discoveries it's going to make inside the Destiny. In spite of its age and the challenges it faces, the spacecraft remains a critical tool for expanding our information of the universe. The scientific community eagerly awaits each new transmission, hoping for groundbreaking discoveries approximately the mysteries of area. Voyager 1's discovery of 500 unknown objects has rekindled our experience of wonder and curiosity approximately the universe. This unheard-of discovery has forced scientists to suppose creatively and push the limits in their expertise. As we retain to discover the depths of space, we have to remain vigilant and prepared for the unexpected. Voyager 1's adventure is some distance from over, and its contributions to science and our expertise of the universe will retain to encourage future generations. An RTG is a type of power generator that uses the heat released by the decay of radioactive isotopes to produce electricity. It converts thermal energy directly into electrical energy through thermoelectric materials. How does an RTG work? Radioactive decay. At the core of an RTG is a radioactive isotope, typically plutonium-238, Pu-238. As this isotope decays, it emits alpha particles which produce heat. Heat conversion. The heat generated by the decay of Pu-238 is transferred to thermoelectric materials, which convert the thermal energy into electrical energy through the Seebeck effect. This effect involves the generation of an electrical voltage when there is a temperature difference across the thermoelectric material. Thermoelectric materials. These materials are usually made of compounds like lead telluride, PBT, or bismuth telluride, by 2Te3. They have properties that allow them to efficiently convert heat into electricity. Thermal insulation. To ensure that the heat from the radioactive decay is effectively transferred to the thermoelectric materials and not lost to the surrounding environment, RTGs are equipped with thermal insulation and radiators. These components help to maintain the temperature differential required for electricity generation. Advantages of RTGs. Longevity. RTGs have a long operational life due to the slow decay rate of the radioactive isotopes used. For instance, Pu-238 has a half-life of 87.7 years, meaning that an RTG can provide power for several decades. Reliability. RTGs are known for their reliability and can function in harsh environments where solar panels would be ineffective. They do not rely on sunlight, making them ideal for missions to outer planets or into deep space. Low maintenance. Once deployed, RTGs require no maintenance or refueling, reducing the need for complex operational support. Applications in space exploration. RTGs have been used in several significant space missions. Voyager probes. Both Voyager 1 and Voyager 2 use RTGs to power their instruments and communication systems as they travel through the outer reaches of the solar system and into interstellar space. Mars rovers. The Curiosity and Perseverance rovers use RTGs to generate electrical power on the Martian surface, where solar power alone would be insufficient. New Horizons. This spacecraft, which conducted a flyby of Pluto, also relies on RTGs to ensure continuous operation and communication with Earth. Design and safety. Design. An RTG typically consists of a radioactive material core, thermoelectric modules, heat exchangers, and a protective casing. The core is surrounded by multiple layers of containment to prevent the release of radioactive material into the environment. Safety. RTGs are designed with multiple safety features to contain the radioactive material in case of an accident or failure. The design ensures that the radioactive material is securely contained and that any potential exposure is minimized. Environmental and health considerations. Environmental impact. The environmental impact of RTGs is carefully considered. The radioactive material used is in a solid form, and the design ensures minimal risk of contamination. Health safety. The levels of radiation emitted by RTGs are low, and the material is safely encapsulated to prevent any exposure. The spacecraft carrying the RTG is designed to shield against radiation. Future developments. Advanced materials. Research is ongoing to develop new thermoelectric materials with higher efficiency and greater longevity. Advances in material science could lead to more powerful and compact RTGs. New applications. RTGs are being considered for future space missions, including those that involve deep space exploration and potential manned missions to distant planets. Notable RTG models. RTG 700. Used in the Apollo Lunar Surface Experiments package, ALSEP, to power scientific instruments on the Moon. Multi-mission RTG, MMRTG used in NASA's Mars Science Laboratory, Curiosity rover, and Mars 2020 Perseverance rover missions, designed to provide power and heat for the rovers. Summary. Radioisotope thermoelectric generators are a critical technology in space exploration, providing a reliable and long-lasting source of power for missions far from the Sun. Their ability to generate electricity from the heat of radioactive decay allows spacecraft to continue operating in environments where solar power is not feasible. RTGs have enabled numerous groundbreaking missions and will likely continue to play a crucial role in future space exploration endeavors.